So good morning students. This is the very important problem and it is previous problem on stress. So already we have discussed analysis of stress problem. So here before problem we have discussed for rectangular beam, but here if unsymmetrical I section is given, how to solve? Okay, the question was an unsymmetrical I section of pre-stressed concrete beam supports a UDL of 20 kN per meter. UDL of 20 kN per meter over a span of 8 meters. It has a top line 600 by 80, web 80 by 280, bottom line 150 by 80 mm, and the force of 150 kN is located at 50 mm from bottom. So 50 mm from bottom of the beam at mid section. Find the stresses developed at quarter span. So find the stresses developed at quarter section means 1 by 4. It is the quarter section. Okay, so first we have to draw the unsymmetrical I section, that is top line, web and bottom line, which is unsymmetrical. Okay, so first one, look at the cross section area. First one, find the cross sectional area. So for calculating the stresses, we have to know direct stress, dead load, live load and bending stress. So if you want to calculate direct stress, dead load, live load and bending stress, we want to know area, moment of inertia and section modulus. So to calculate it all, so we should find first cross sectional area. So cross sectional area for first one, 600 into 80 plus 80 into 280 plus 150 80, we will get the value of 0.082 meter square and 82.4 tan cube mm square. So this is the area. So first one, if it is symmetrical, we can detect the neutral axis equal. If it is unsymmetrical section, so how to find the location of neutral axis? Already we know, we calculated in SN, strength of materials. So y bar is equal to area into H plus, okay, area into A1H1 plus A2H2 plus A3H3 by A1 plus A2 plus A3. This is the formula. So total area. So area of first section 600 by 80 into H bar and centroidal distance. So 80 by 2 40 plus 80 into 280, 220 into 280 into 80 into 220. How will we get 220? So this is the centroidal distance. So here 280 by 2 plus from top onwards, this is the centroidal distance for web. So 280 by 2 plus 80, that is 140 plus 80, we will get value 220. 140 plus 80, we will get the value 220. Next 150 into 80, central distance 40. So this is the location of neutral axis. We will get the value 298.6. So that is y bar, that is equal to 298.6 mm. So here, so remaining the overall 80 plus 280 plus 80, that minus 298.6, we will get the value of this one. Okay, so again, but here we get it has given the force 150 kilonewtons, which is located 50 mm from bottom. So eccentricity we want eccentricity means, so for this eccentricity we are taking 298.6 minus 50, locate the eccentricity is 248, e value 248.6. This is the e value. So here what is the eccentricity means 248.6 e value. So here main important eccentricity. Why? Because for calculating the bending stress we should want value eccentricity P into E by Z. So here E 248.6. Okay, this is the y bar and the eccentricity. So here now comes main neutral axis. So moment of inertia at neutral axis. So I value should calculate for moment of inertia for neutral axis. Okay, why? Because it is unsymmetrical section. So we want to calculate the moment of inertia for neutral axis. So here for neutral axis we know Ixx plus AH square. Okay, so Ixx for all We know BD cube at 12, BD cube at 12, BD cube at 12. Area 600 into 80, 80 into 280, 150 into 80. So 600 into 80, 280 into 80, 150 into 80. So here H bar comes here how? So how it comes from H bar means 141.4 minus 40, 141.4 minus 40. How we will get the 141 means the remaining height. Okay, so the remaining height how? Because 80 plus 280 plus 80 we will get how much? 80 0 8 3 is 24 440 minus 298.6 we will 440 minus 298.6 we will get 141.4. This is the value of remaining 141.4. This is the remaining. Please listen. So this is how we will get 141 means overall length height minus 298.6 we will get 141.4 minus half distance. So 141.4 minus 40, 141.4 minus 40 square. Next here, so below the neutral axis means, so we can take directly value 298.6 minus 220. How we will get 220? This one. So 220 means how? So same 280 by 2 plus 80, 280 by 2 plus 80, 220 square. Next 298.6 minus 40, 298.6 minus 40. Only we should remember how we will get the 141 means this line 80 plus 280 plus 80. Okay, so here overall by calculating the neutral axis of moment of inertia, so we get the value 1612.7, 1612.7. So I already told you should calculate the section modulus at top and bottom. Section modulus at top and bottom. So ZT is equal to ZT means section modulus at top I by YT. So I by YT. So I value already I got 1612.7 10 power 6. YT is nothing but top section. So that is 141.4 and bottom is 298.6. 298.6. This is the bottom. So neutral axis above means top, neutral axis below bottom. So here